Hey guys, my name is Matthew Sloan, and welcome back to another Chem video. Today we're going to be talking about Aspergillus. What is Aspergillus? Aspergillus is a common mold that is found indoors and outdoors in many different climates. In the genus rank under the fungi kingdom, this eukaryotic organism is known to cause serious infection in the human body. This disease is known as aspergillosis. The structure of this fungi is nothing short of complex. It consists of a circular shaped vesicle, as we can see here in this photo, with filamentous extensions growing out of it. Its protein structure also resembles a spherical shaped exterior, which is noted here in this round circle. And we can note that it has an asymmetrical shape to it, and it is a monomer. Continuing on the structure, we're going to look at the primary, secondary, tertiary, and quaternary categories and what consists of each. So moving through those, apart from what we visually identified in the last slide, we can categorize the structure based off of these four different structural groups: primary, secondary, tertiary, and quaternary. Primary is basically going to be a linear amino acid chain, and through our image here, going back on it, looking at this primary category, we can identify the linear amino acid chains here, and it's consistent throughout, and we can see it throughout what we're looking at here. So moving on to our second category, which we see as secondary. Basically what it is it's going to be a local folding in the peptide chain consisting of an alpha helix and a beta pleated sheet. And again, same thing as primary, we're going to be looking at this alpha helix here and these beta pleated sheets here. And again, it's consistent throughout, so our secondary category is also satisfied. Moving through to the tertiary category, it's going to be a three-dimensional folding due to side chain interactions. That being said, looking at our diagram here, it looks very close to an alpha helix. However, these foldings are occurring in more of a close manner, and they're almost wrapping each other up together. So if we look back at our diagram here, like in this section right here, where everything's very close together, there's going to be some of these alpha helixes that actually overlap and kind of come together in this area, which is going to satisfy that tertiary category. So moving on to the last one, if we want to look and see if it is also satisfied, a quaternary category is going to be more than one amino acid chain in our full diagram, and we can identify through this that we actually have two amino acid chains throughout, and it can't be seen very well in this diagram, but if we actually do break it down and spin it a little bit and zoom in, we can identify that there are two amino acid chains here in this. So that being said, all four of these are satisfied, so it does fall under all four categories. So moving on, what is its purpose and what does it do? Basically, Aspergillus serves the function of recycling carbon and nitrogen. In the human body, it's most commonly found in your lungs, but it can also be present in your sinuses. That being said, again, we want to remember that it can make us super sick. It is a fungi, and it does infect our lungs, and it can cause great pain to our immune system. So that being said, we want to move on. What are amino acids? Really breaking it down to get a good understanding of what all of this is. Amino acid is going to be what really is our building block to create our proteins. And so that being said, an amino acid is simply just a molecule that combines to form proteins. So, and again, it's our building block. So we do want to keep that in mind when we're looking at these diagrams and when we're looking at these structures. So moving to the next part of this, here's our amino acid sequence for Aspergillus. And again, it's quite long. It's got 51, 61. It's got around 281 different characters in the sequence. So again, it's pretty complex. What we're going to do in this video is we're going to take a look at these first 10 and these next 2 slides, and we're going to see what we can do with regards to converting them. In this video, we're not going to go into too much depth on how to convert them, but we are going to look at what they convert to in DNA and RNA. So we're going to start with DNA first. The conversion can be done through using codons, which is going to be kind of complex, and we can go over that in other videos. But in this video, what we're just going to look at is what the translation roughly looks like. So here's our amino acid for our first 10. If we want to go back, we can identify that these are our first 10. And this is what it's going to look like in our DNA form. So that being said, now that we've identified what our DNA form is, we can directly convert this to RNA, which again, it's going to be a little less complex than going from protein to DNA and having to use our codon tables and figuring all of that out. However, it's still going to be a difficult process and something that we can go over in the future. But again, here's our DNA form. Here's our RNA form. Looks pretty cool. But other than that, that's all for this video. Hope you got a good understanding of what Aspergillus is. And we will build off of this in videos to come. Thank you guys for watching. Have a great rest of the night.